Hi, in this video we're going to introduce angle sum and difference identities, and we're going to look at at one of them and how it's formed, and then in the next video we'll look at some examples as well. So solve problems using the angle sum and difference identities. So what we're going to look at in this video is how to derive the angle difference identity for the cosine. So for instance, we know that cosine is x over r, or adjacent over hypotenuse, but that's for a single angle. Turns out we can add and subtract angles together and then take the cosine or any of the other 5 trig functions of that result. So we're going to use A and B in this case, but you can use whatever you like. So here we have a unit circle with a radius of 1. And let's say angle A, just for the purposes of arguing, is in the third quadrant. It has an x coordinate of cosine and a y coordinate of sine. So the x and y coordinates of this point are cosine of angle A and sine of angle A, respectively. Likewise, angle B, let's just say it ends here as well. It just so happens to be in the third quadrant. Again, unit circle, and we have, for this point, the x and y coordinates are cosine of B and sine of B. So what we have here is, if we put the 2 points in the same plane, then what we have for the angle that the 2 sides, the 2 radii make, is this is angle A, and then this is angle B, so that the difference between A and B is the measure of the angle between these 2 radii. So looking at the fact that the radius of a circle never changes, so all these sides are the same length, we can even make an angle of the same measurement as we have down here. And now we have 2 triangles that are congruent by side angle side. We've just reset this triangle. It's almost as if we just rotated this triangle to be in the first quadrant where one of our points is at 1, 0. So if we look at the distance between the cosine A, sine A, and cosine B, sine B, in other words, the distance between these 2 points, the length of this dashed segment, then it's the difference in x values, cosine A minus cosine B, the difference in x values squared, plus the difference in y values squared. So it's Pythagorean theorem. Expanding all this out and then doing some simplification here, notice we have cosine squared A plus sine squared A, which we know to equal 1, cosine squared B plus sine squared B, which we also know to equal 1. So that's where these 2 1s come from, and then we just copied each of the other long terms here. And so combining our like terms, we have 1 and 1 is 2, and then copying everything else down, we're good to go. Now for our other point, which, just going back, this length here, this dashed length, which has an x and y coordinate of 1, 0 for one point, and an x and y coordinate of cosine of A minus B and sine of A minus B for the other point. We know that these 2 purple dashed segments have to be equal. So now what we're going to do is we're going to find the distance between these 2 points, and then we'll set the 2 results equal to each other, and it'll give us our angle difference for cosine. So once again, we're finding the distance between the cosine of A minus B, sine of A minus B point in the first quadrant, and the 1, 0. So multiplying this out, we end up with this nice radicand expression in here. Here we have cosine squared A minus B plus sine squared A minus B. And again, even if it's A minus B, if it's cosine squared plus sine squared of something, that it's always going to equal 1, as long as those A minus B, as long as those angles are the same. So we have cosine squared plus sine squared is 1. Combining the like terms, we have 2 minus 2 cosine A minus B. So setting them equal to each other, we can square both sides to get rid of our square roots. Notice we have a 2 here and here, so we can subtract the 2's. And now we have negative 2 cosine of A minus B equals this nice expression over here. So to get cosine of A minus B by itself, just divide everything on both sides by negative 2. And we have cosine of A minus B equals cosine of A times the cosine of B plus sine of A times the sine of B. So don't forget dividing by a negative. All right, so that about does it for this video. Thanks for watching. I'll see you next time.